the stop button over and over again. Thank you, Gabby. All right, we are going to look at 12.7, exploring similar solids. Okay, we know what similar is. We dealt with similar triangles, right? They have to have the same what? What is that magic word that they have to have the same thing?
Shape.
Ratio. Okay, they do have to be the same shape as well. Okay, those are both true. They have to be the same shape, have the same ratio. Because if you're looking at a triangle to a square, I don't care if they have the same ratio. They are not similar to each other. All right. Two solids of the same type with equal ratios of corresponding linear measures, such as height or radii, are called similar solids. The common ratio is called the scale factor of one solid to the other. The two cubes are similar. Two cubes are always similar, as well as two spheres. So this is the important part. We know a ratio is A over B. Okay? That means their linear length, their height, their width are similar. They have the same scale factor. But if we're talking about their surface area, we square it. If we're talking about the volume, we cube it. Yeah, that's what we've been doing. With volume is cubed, surface area is squared. Okay, so we've got two rectangular prisms. So our first criteria is done. They're the same. They're similar in shape. Now we have to make sure they have the same scale factors. Okay, so this one, this length right here, 4, would go with 8. So I'm going to put 8 over 4. This 4 back here would go with this 2 back here.
Wait, does it matter which one you put on top?
Well, I'm putting the big one on top of the small one. As long as they're all the same, you're good. And then their heights are both 2. It's just my crazy drawing. But we're going to talk about whether they're similar. Okay? 8 over 4 reduces to 2. 4 over 2 reduces to 2. But 2 over 2 reduces to 1. So are they similar?
No.
Not similar. It's like we're looking at these at different perspectives as well. You know, one you're looking head on, one you're looking side on. Okay, so that's the easy part. Now we're going to get very slightly more difficult. Are you ready?
On the back?
Yep, we're on the back. Okay. We know their surface area and the volume of 1. We want to find the surface area and the volume of pan 2. Okay? It tells us they are similar and their scale factor is 87 over 100. Okay, that's very large scale. All right. What are we going to have to do to the scale factor in order to use it for surface area? Yes. No, it is simplified as much as it can be. What did it say up here when we're using surface area? You're going to have to square it. Okay, so let's square them. So we're going to take 87 squared, which is 7,569, and we're going to take 100 squared, which is 10,000. Okay, so that's my new scale factor that I'm going to be using. And what do you think goes on the top? Which side went on the top? 87 was for can 1 or 2? Which one? 1, because it's smaller, right? That's how I know. Okay, so I'm going to take my scale factor for surface area. And I know the surface area of the small can, so I'm going to put that on top. But I don't know the surface area for the large can, so I put a what on the bottom? Okay. And then what do I do? Cross multiply. 10,000 times 51.84. We should just be able to move the decimal places over. We get 518,400. And then what do I do with that? Divide by 7,569. And I get that the surface area is 68.49. Let's round it up to 2 decimal points in inches squared. Okay, but it said what? It said 2 things I had to find. The volume. So instead of squaring them, we're cubing them. We're going to be dealing with some big numbers here, huh? 87 cubed is 658,503. And 100 cubed, should be able to do this in my head, is 1 million. Wow.
surface area.
Because you've got to find the surface area and the volume, just like that. Okay, now we're going to take the volume of the little one over, we don't know what the big one is. What if we knew what the big one was but didn't know where the little one was? Where would the x go? So now I'm going to get 658,503x equals, sometimes they're big. When you cube something, it gets really big. 282,740 is 1. It's a million. 100 million would be 4 zeros. Divided by 658,503. And I get that the volume equals, I hate that saying, 42.93 inches cubed.
Hey, what's it?
Doing too much.
Wow. That huge number turned into that small.
Yes, it did, because we divided a really huge number by another really huge number. Give us a smaller number. I say volume weird. I know. I say volume for some reason. Yeah. Okay. Are we ready to do example 3? Example 3. The pyramids are similar. Thank you. Okay, pyramid B has a volume of 1,000 cubic inches, and pyramid Q has a volume of 216 cubic inches. Find the scale factor. So what are we going to have to do to this? So first of all, do you want to put the little one over the big one or the big one over the little one? Little one over the big one. So we've got both of their volumes. How do I get back to their side scale factors? You're almost there. So if it was surface area, you would square root it. Since it's cubing, we cube root it.
How you do that?
Yep, and I'll show you how.
Cube root it.
So you take your calculator and you raise it to, you use a little caret symbol. So for example, you write 216, this little thing, parentheses 1 divided by 3. If you take something to the 1/2 power, it's the same thing as square rooting it. So if you take something to the 1/3 power, it's the same thing as cube rooting it. And we get 6 over. Anybody want to take a guess what the cube root of 1,000 is? 10. And then we reduce it to 3/5. Wait, so how is it? Okay, so if you look at your calculator, you push in, if you type in 216, and then put the little, we call that a caret, it looks like a little triangle type thing, and put in 1/3, it cube roots it for you. So 6 times 6 times 6, you type it in your calculator, 6 times 6 times 6, gives us 216.
Hold up. This thing sucks.
Well, I always have calculators back there that you can use any time. Yeah,
Can I use that one?
You can use it for today.
We need